Welcome to lecture series 8051 microcontroller. In today's session we will discuss about how to interface the LED with 8051. Already we have discussed the architecture of 8051 which have a 4 ports, right, port 0, port 1, port 2 and port 3. So, 4 ports having each 8 bits. So, totally 32 bits are available. So, in the 32 bits any bits can be used as a either input ports or output ports. So, here we consider as a display, so which is output source. Okay. So, in this how the LEDs are connected in the ports, each port having the 5 volts. Okay. So, if suppose you are applying the value 1 means then LED will glow, or if you are applying 0 the LED will glow means based on the forward connections or reverse connection, reverse bias it will conduct. Okay. So, based on that you can consider. Today we will discuss how to write the program to glow the particular LED for the particular bit positions or group of LEDs, okay, or all LEDs to be on or all LEDs to be off. For which port you want you can use it. The port is nothing but simply you can initialize your required data, what are the bit positions to be on, then you put it as 1 remaining as 0, then you read it in the hexadecimal, you move it into the accumulator, right. Accumulator will move to your required ports. Suppose port 2 means move port 2 comma accumulator. Now, the available bit positions are moved to the port. In the port you physically connected the LEDs, right. Based on ones and zeros the corresponding LED will glow. Okay. Then if you want to define the delay, how long it want to switch on, that is glow the LED means you can initialize the delay value. This is a normal LED connection. Suppose if you have a 7 segment LED display, how to interface it, right. In today's session we will discuss about how to glow the single bit LED or the group of 8 bit LEDs, then how to write your own required alphabet in the 7 segment LED display. So, first we will discuss about the single bit LED. Suppose I want to display the single LED in port 1. Okay. So, the port 1 I have taken port 1.3, port 1.3 is connected with this kind of LED. So, this what it represents, if you are giving 1 the LED will glow, if you are give 1 the LED will glow. Okay. So, in that case this bit will be activated by using the set bit P 1.3. So, by using this will on. Suppose the same thing if you are connected in the reverse bias, then by giving the 0 value only you can glow the LED, because this is a reverse biased. Suppose you are take it as port 1.7, then you have to give CLR P 1.7. So, by this instruction now this LED will glow, by giving this instruction this LED will glow. Either by that you can give, or you can write the standard program which is move a comma, what is the bit position of this, you can write P3 as P 1.0, 1.1, right. So, till 1.7. So, this is a 3 means 0, 0, 2, 3, right, then 4, 5, 6, 7. You can read the corresponding binary equivalence, only the particular LED to be on. So, I will give it as 1, remaining signal as 0. Now, read its corresponding hexadecimal value which is 08H. Okay. Now, the 08H is loaded, this to be which port you want, suppose simply instead of giving you are giving port 1. So, move port 1 comma A, right. Now, the corresponding data which is 08 is moved to port 1. So, in the port 1 means only the P 1.3 having the 5 volts remaining as 0 volts. So, only this LED will glow, remaining LED will off, or no need to connect the other LEDs also. Now, if you wish you can use the call delay, then you simply jump the, this is a simple program to activate the particular bit. Suppose you want to activate the bit position of 1, 1.1 means here you put 1 remaining as 0, right. The same program you can use it for the other LED to on. So, instead of 08 here you have to give the value as 0 to H. So, any one of the LED from this 8 bits you can switch on, right. Suppose you want to switch on the 2 LEDs, means instead of one, if you want to switch on the first one and last one, right, LSB and MSB, means now you read it, what will happen, 8 and 1, 81 H. Okay. If you are giving 81 H, the LSB MSB will be on. Okay. So, this is a simple program which is used to activate the particular LED. So, the particular LED, either you can use it by the set instructions, or you can initialize the corresponding binary equivalents into the accumulator, then the accumulator content is moved to your required port, then you can use the delay. Delay, you can use the maximum delay, just to initialize move or not comma FFH, then decrease, jump, not 0 or not to here, then it return instruction. Now, we will discuss about the 8 LEDs, port 2.0 to port 2.7. So, 8 LEDs commonly connected. Now, you want to activate the program, right, all LEDs to be on or toggle the flip flops. Suppose all LED to on means what you will do, move A comma 00 H, right. So, all the LEDs will applied with the 0 volts. So, it will off condition. Now, in which port you want to display the LED means port 2. So, port 2 comma accumulator. Then suppose for 1 millisecond it to be on or off means you can use the delay. Now, you can stop the program. Suppose I am asking the 8 bits to be on and off, okay. That is toggle means what you will do? Yes, CPL A. CPL A means 00 become FF, right. Now, you simply pass to the port 2 and call delay. So, use the short jump for repeater. So, now what we are doing, the initial value is initialized, right, then move to accumulator. By this case, now all the LEDs are in off condition, then call delay, then complement. Complement means automatically all the bits in accumulator become complemented. So, it become FF. So, now the FF value in the accumulator is moved to the port 2. Okay. Now, after passing to the port 2, all the LEDs will be on, because you are giving the value 1 which represents the plus 5 volts. Okay. Then again you are repeating the same process. So, automatically this program which is used to toggle the bit positions. So, either you can give all the LEDs to on and off, or alternate LEDs means instead of 0 you can give it as 5 means instead of 0 1 0 1 0 1 0 1. Okay. So, this is read it as 5 which is port 2.0 to port 2.7. Okay. So, how you want to switch on the corresponding LEDs, you can put 1 and 0. If you are connecting in the forward bias, it will be activated by applying the value 1. Okay. So, 1 means what it represents, you are giving the plus 5 volts. Okay. So, you can switch on, write the program, whatever the value you need that should be initialized in the accumulator, then move to your required port. So, required port means already you have the physical connections with the corresponding port. Now, your content will be moved to the port, means in the corresponding ones and zeros become 0 volts and 5 volts. So, 0 volts means there is no glow of LED, 5 volts means the corresponding LED will glow. Okay. So, you can visualize how the program will execute in your breadboard. Okay. You make the physical connection in the breadboard and check it by using this program. Next, we will discuss about the 7 segment LED display. 7 segment display, already you know this is the 7 segment display, right. Okay. The 7 segments of LEDs are connected, that is why it call it as a 7 segment LED. So, the each LEDs are named it as A, B, C, D, E, F and G. Okay. These 7 segment LEDs, okay, how it was connected means actually this is the 7 segment of LEDs. Okay. Each LED is assigned with the corresponding alphabet. I will write the corresponding name. This is A, B, C, D, E, F, G. Okay. So, these are the 8 LEDs are given in this structure, that is why it call it as a 7 segment LED. Okay. These LEDs may be connected in the negative side, means this is call it as a common cathode configuration. In common cathode configuration means how the LED will glow, by giving the value of 1 the LED will glow. Okay. In case of common cathode, you have to give the +1 to activate the value, right. Suppose these LEDs are commonly connected on this side, means it is connected with the +5 volts, because this is the anode terminal, right. Now, you want to apply the 0 volts to switch on this LED. So, this kind of configuration is called it as a common anode configuration. Okay. So, by this way only now we are planning to switch on the corresponding bit positions or switch on the corresponding LEDs. Suppose I will write the alphabet A, B, C, D, E, F, G. The last one you can consider as a decimal point, you always consider it as a 0. Now, I want to switch on or display the value of 4. 4 means what are the LED to glow? F, G, B and C. Okay. So, these 4 LEDs to glow to give the letter 4. Okay. So, for that, this is suppose I am connected with the common cathode configurations. So, common cathode configuration means I have to give 1 to switch on the LED. So, A to be off, so I will give the 0 volts, B to be on, so I will give 1, for C 1, then D is 0, E is 0, F is 1, G is 1. Okay. So, now read it in the hexadecimal, which is 66. So, by giving the value of 66, you will get the 44. Okay. So, now how we are writing the program means move A comma 66H. Okay. Then move, suppose I am connected with port 1 means port 1 comma accumulator. So, how this connection is available means this is 8051, which is connected with the 7 segment display. This is a port 1 signal. So, port 1.0 to port 1.7, right. So, this A will be connected here, okay, B. So, like that you assumed it, this 8 including the decimal point will be connected to the 8 pins in the port 1. So, based on this signal, suppose in the port 1 you are moving the signal 66 means what will happen, the corresponding bits will be on. So, these LEDs only forward biased, so it will be switch on, remaining LEDs are off condition. So, it is not display. Okay. So, this is the way we are using, then you can use the suppose you want to display this value for some particular time means you can use call delay, and short jump you can stop the program. This is a simple way. If suppose I am asking you to display the word ball, okay, in the same common cathode configurations. So, what you will do or how you will write the program? Okay. A, B, C, D, E, F, G. Okay. Decimal point consider as 0 always. So, I am asking you to display the letter ball, right, B, A, then L, L. Okay. In B means all the LED to on. So, I will give the all 1 value. Okay. Now, you read it. Okay. For A, except what is that, A, B, C, D, except D. So, I apply the value 0 to D, remaining is 1. Then you read it. Now, for L, right, A, B, C 3 bit positions are off, then D is on, A, B, C, D, E, F, G, right. Now, you write the corresponding bit positions E, F, then G off, this also off. The same thing for another L also. So, now read the bit positions, whatever it comes, that should be you have to initialize in the memory. So, this is read it as 7F, this one is 77H, this one is 38, then 38H. So, these datas I have want to display. So, I want to initialize in the memory 20H. Okay. So, 20 means 20 for 7F, 21 for 77, 22 for 38 and 23 for 38 also. So, now I will initialize the memory, that is R naught, R naught into the starting address is 20H. Then how many character you want to display, that is initialized in the R1 register, which is 04H. Okay. So, here the content of the ball will be available. Here the number of letters or characters will be initialized. Okay. Then these two are the initialization. What is the next step? Now we have to display the value. So, to display the value, it should be moved to accumulator, right. So, first letter I want to move it accumulator comma at R naught. So, by this the letter B is moved. Where you want to display? Suppose in case of port 1 means you will move port 1 comma accumulator. So, now the B is displayed on that 7 segment display. Then you can use the call delay, because minimum delay at least you have to give, otherwise you cannot see the character, because the execution time of microcontroller is very fast. Okay. So, if you are initializing the delay, you can see the text B on your 7 segment display. Then what I have to do? After that I have to call the next letter. So, for that I have to increase the memory location, which is R naught. This is second letter. So, I have to decrease the R1, or simply you can use the same instruction, decrease and jump not equal to 0 of R1 comma repeat I will give it. Okay. So, the first character is moved to accumulator, then displayed on the 7 segment display. This is the instruction which is used to display on the 7 segment. Okay. The content based on the ones and zeros, it will apply the 0 volts or 5 volts. Then you are giving the delay to view that character. Then increasing means you are calling the next memory location, then decreasing. Now, by the increased the R naught become 21, the 21 content is 77, which is B A. A will be displayed by using this instruction, then again call, again increased, it is not equivalent to 0. So, move and give the letter L. Okay. So, again it also comes L, then whenever the R1 reaches 0 it will exit, you can stop the program by giving the short jump. Okay. So, by this way you can display your own character on your 7 segment display device. Okay. So, first you initialize the memory as per your desired location, then the number of characters, okay. Then that should be initialized, then move the first character to accumulator, then move to the port, then call the delay, then repeat the same process. So, I hope you get a clear understanding how to design or find the hexa equivalent for your required character. Suppose I am asking you to generate the natural numbers up to 9. Okay. So, 0 to 9 I am asking you to display. So, first you have to find the corresponding hexa equivalent for 0, then 1, then for 2, then for 3, okay, then for 4. So, like that you find the text character for 9, up to 9 you find it, its corresponding hexa equivalents you load it. Okay. The same thing what we have discussed in the previous program, you can initialize the memory starting address with 20, then counter number as 09. Okay. So, by this you can use the same program, only here the starting address instead of ball you are planning to give 0 to 9 its corresponding hexa equivalent, then instead of 04 you can give the number 9, because 9 text you are want to move it, right. So, the same thing you write it A to decimal point, then you write the corresponding ones and zeros, what are the LEDs to on and off, right. Simply I will give for the first one 0, then remaining you will continue and do it as a homework. So, A to be on, then B, C, D, then E, F, G is 0, decimal point is 0, right. So, this 0 for 0 you have to give the value as 3 F H, for 1 means only C and D is 1, right, remaining are 0 0. So, this fully 0. So, 0 6 you have to give it. So, likewise you develop and give it. Okay. So, I think you can easily generate the same program. Now, I am asking you to write the another program. I am asking you to add the two number, right, 5 plus 3 and display the result in the 7 segment LED display. Okay. So, for this how you will write the program. So, first one of the data to be moved to the accumulator for addition, right. So, I will initialize the first data in accumulator. The second data you can move it in any one of the register, right. I will select R1 which is 03. So, the two data is first the initialization is over. Next what you have to do? You have to do the addition. So, for addition I am using the instruction add, right, A comma R1. So, here what will happen? The accumulator is added with the R1, the result is stored in the accumulator. Now, I am asking you to display the result on the port, suppose port 2. In port 2 means what it will already available in the accumulator, right. Simply you give the data port 2 comma accumulator. So, now based on the ones and zeros in the binary equivalence of the resultant value. So, accumulated value is 8, right. So, 8 means 1 0 0 0, okay. Only 4 LEDs are planning to use it. So, based on that only the 4 bits in the port 2 will be switched on, remaining will be considered as 0 0, okay. Then you can use the short jump. So, this is a way we are planning to execute how the sum and the resultant value will be displayed on your program. And one more thing, suppose I am asking you to read the data from port 1 which is connected with the switches, okay. Then display the data to the LED in port 2, okay. So, this kind of program I am asking means what you will do. So, you can use move A comma port 1. So, whatever the switches are present, based on that value will be moved to accumulator. Now, you can move port 2 comma accumulator, okay. So, this is for read operation, this is for write operation. So, this is will display the value in the LED if you are made the physical connection. So, if you want to give some delay to make the process without any overlapping means here you can initialize the delay, okay. So, this is a way we can do the read operation from the external switches and you can display the result in the external LED display. So, in today's session we have discussed how to interface the LED with the 8051. So, the 8051 have a 4 ports, right. So, among the 4 ports 32 LEDs are possible. So, any one of the port you can take it, any one of the particular LED you can switch on and off it, or the group of LEDs you can activate it, or the particular port can be connected with a 7 segment display, you can activate the corresponding digital display, okay. So, here what we are doing means whenever you want to send the data to the LEDs means the data to be loaded in accumulator, then via the accumulator we are passing to the port, then the port will give zeros and ones for the LED, then it will be switched on. This is for the read, that is write operation, we are sending the data. Suppose if you want to read from the external switches means you have to get it via the port to accumulator, okay. Either port to accumulator is a read operation, accumulator to port is a write operation. So, I hope you enjoyed and you can get the clear understanding how to interface the LED with the controller. Thank you.